I get started just a couple minutes early. Before I do, have one quick announcement. Scale, another local conference, more sysadmin and open source focused in LA. Their call for papers is open now and I believe closes next month. So if any of you are so inclined, might check that out. All right, so as I said, we're going to start just a few minutes early here because short spot and he's got a lot of stuff to say. So without further ado, this is Vyrus.
Hello. Check. Talking. Hello? Hello. Yeah, so I apologize. Originally, I was really afraid of rehashing content from my Balkan talk because that's why on a lot of the stuff I'm going to cover today, and today is more of a like how to do all the evil stuff. And then like 10 minutes into making these slides, of them and had to edit a bunch. So I apologize in advance. I'll probably talk extremely fast. So what we're going to talk about today is just kind of a tips and tricks of skills I have acquired over time in scenarios I will not describe because plausible deniability, on basically how to write long-term intelligence gathering software. Basically like, you know, spyware or what some people will call APT or just the actual scary stuff that sits inside somebody's box for not days like a pen tester, but like months, days, or months, weeks, years, that kind of stuff. So from a kill chain perspective, like we want to get into organization. At the end of the day, an organization is just a collection of people, right? I mean, it doesn't have to be a corporation. It could just be a group of friends. It could be terrorists. Who knows? At the end of the day, people from an information security perspective, aside from human int, are really just the devices and the data that's on them. So our kill chain in this vector and for the duration of this talk is basically how do we get on a thing and stay on a thing for a long time and steal fucking all the things all the time for long periods of time. That's our kill chain. So the obvious and most plentifully used and talked about method for doing this is phishing. The problem with doing long-term surveillance via phishing, there are a lot of good things, obviously, in terms of entrance, but there's a lot of downsides. Typically, if you talk to a pen tester, they'll say, well, phishing's nice, but phishing's really loud and can typically unelegant. Well, that's great, but you know, over time, you know, when you're trying to stay in for long periods of time, it's not as simple as, oh, I've got a Metasploit shell, and that means I can access DA, and everything else is not a thing. So on the good side, it's really easy. You typically get multiple shots at the target, even if you're spear phishing, right? I mean, you create an identity. It may take you months. You set up a false rapport. It takes time to initiate the kill, and then if you don't get what you want, you just do it all over again, right? There's nobody immune to social engineering. We all know this. If you don't know this, you're fucking wrong. There's literally no technical specificity required for most phishing attacks. I mean, really, like, you can Google everything you need to know to be at the absolute pinnacle of social engineering. It's not, you know, you don't have to know how to reverse binaries or write ODE. And the great thing is that generally, if you're successful at any level of phishing campaign, you get access as that user. So even if you're not root, if the purpose is intelligence gathering, you usually get enough access to do what you want to do the first time. You don't usually have to worry about privileged access. On the bad side, phishing is really loud. It's almost impossible to carry out any level of social engineering without leaving some kind of trace. I mean, you can nuke logs, and you can leave fake logs, and you can, you know, leave yourself social exit strategies. But for the most part, considering the technical impact, phishing is generally loud. It generally leaves a lot of evidence, even if all you're doing is an email that's in some third party's log that you can't remove. Spear versus net, obviously, like, the net phishing is probably almost certainly going to get detected, but it'll look like innocuous. But that being said, if it's effective, it probably can't look innocuous enough to, you know, be attributed to some spammer on the internet, which means somebody's going to investigate it. If it's a spear phish, it has a much higher likelihood of success, but your tricks look unique. You don't look like a garden variety attacker. You're more likely to get profiled. You're more likely to get caught. It's generally high risk. Compared to technical variants, like if a phish goes bad and somebody's randomly using a computer and they get an error message that like breaks their machine, that shit gets investigated, right? It's not like, oh, you tried to launch ODE at some process and the program died, because that shit happens all the time because program's poorly written, right? Like nobody knows how to write software, no big deal. Generally, if you're going after a hardened target, you're guilty until proven innocent. Like if you're going after like something that's paramilitary or somebody who is afraid of the government watching them or some like activist or something, like these are generally hardened targets. Looking for shit to fail, they're generally paranoid. When something randomly fails on their box, they're going to notice. And when they notice, they're not just going to go, oh, nothing like a typical user. They're going to actually investigate. They're going to Google a DEF CON talk on how to do DFIR. Like you're going to get caught. So in terms of phishing, if you're going to do it, right, we'll talk about vectors. So I don't know, probably the most talked about vector these days is Office, right? Going in through Word docs, Excel docs, PowerPoint presentations, stuff like that. So pretty much, if you're going to hide a payload in a Word document, go Google this guy right now. He's got a tool that I know the last time I talked to him, he was trying to get open sourced. I believe that's still on the agenda, but there's some issues with work and blah, blah, blah. I've seen it. I wish I could show it to you. But he has given some talks on what it can do, and it's pretty much a point and click like GUI on like make bad stuff out of Office, and there's way more tricks. It's just an awesome, it's like the Metasploit of making Office malware, and like none of this stuff gets caught. Most Office payloads are based around macros, and this is pretty much how you write a macro. It's not hard. You pretty much take whatever your evil stuff is, you stick it between those two lines of code in the macro area of Word, and you click save. Done. To be more specific, oh no, internet being slow, not loading my pictures. This is going to be a really weird presentation without pictures. So this is an example of a payload. This is one I used. Unfortunately, the logo is not showing up, so this is going to be pissed at me. This was generated by Vis over at Phobos. We use stuff like this on a gig that we did together a while back. This is just like a copy-paste example. Like if you want something, you can immediately paste into Word and make it load a malicious thing. This will load calc.exe, but this is an example of like paste this, get shell, right? Or deploy long-term payload. More recently, I've only used this in POC because it's new to me. This is like the DDE trick, which everybody's talking about on Twitter right now. This is actually really interesting. So basically, it turns out that anywhere on Office where you can add a mail merge field, you can add a function in the same way that you would add like a function in Excel. Turns out you can make functions called programs. Lol. So I highly recommend going to these guys' Twitter feeds and looking at the pin posts because they've got a blog that I thought I had. There we go. This blog pretty much explains how to do it. There's no point in me copying their screenshots because it's all there. It's a really awesome how-to on how to get their POC working. And that line at the bottom is literally if you paste that into a field, like when you open a document, it'll call calc. Like that's an example payload. Other methods of social engineering getting on a system. There's the BDF proxy SIGThief combo, which I'll have a picture in the following slide, which kind of shows how that's encapsulated. BDF proxy is this awesome, awesome, awesome tool written by this guy named Josh Pitts that we will talk about, or I will reference at least 5 times throughout this talk. Long story short, it analyzes files, usually binaries, and finds things called code caves, which we'll talk about later. And basically, it takes malicious code and sticks it in that code cave so that that file is essentially backdoored. And it works on all kinds of shit. It works on all the binaries on Linux, all the binaries on Windows, all the binaries on OS X. It works on a bunch of web payloads. It works on documents. It works on, like, fucking everything. And he is no longer maintaining it, but it's written in Python, and it's all the dependencies are largely documented. So if you want to take that functionality out and put it into something that is standalone and self-contained and autonomous, it's really relatively straightforward. The code's relatively well documented. More importantly, especially if you're dealing on modern operating systems, the problem is, yeah, I can backdoor a binary, but it's going to change the signature, right? Well, he has a new project, which he just talked about, I think, a couple of weeks ago, called SIGThief. SIGThief is awesome. I honestly haven't had a chance to look at really the internals to know how the hell it works. It's fucking voodoo. But basically, you take a signed binary that fits certain parameters, and you say, steal this signature. You take that signature, you backdoor the original binary, and then you add the signature back, and nothing has changed. Holy shit, nothing finds this. Please use it. Evil grade, I talk to a lot of pen testers who basically come at me with like, well, evil grade's great, but, you know, SSL makes things not work. For those of you that don't know, evil grade is a man-in-the-middle trick / utility that it listens for HTTP requests for update servers, and as the update comes down, it backdoors the update and then sends it in. Actually, BDF, Backdoor Factory Proxy, has like a proxified version that kind of does what Evil Grade does. Yeah, so like the SSL thing and how, the app connects and it doesn't, it gets a different cert, and so that means it's not going to work. Yeah, that's true for like, honestly, in the real world, like 10% of live targets. Because yeah, it's not going to work on like a Windows update, but like Sublime and fucking games and so many little stupid third-party pieces of software that people use, like little Steam updates that people don't use. Game cheats are a great one, right? Like people download porn all the time with little like auto executor stuff. All of that shit ignores the fucking SIG, okay? It connects, the cert goes bad, and there's a silent thing in the back that goes, well, fuck it, I still want the update, and it installs. Yeah, the SSL does not kill any of that shit. Beef is a modern pen test framework for browser exploitation. I had a demo that I was going to show you that I didn't have time to write because I'm a new dad and babies are complicated. I just got it working, and unfortunately I don't have it portable enough to show you. I'll probably drop it on my GitHub when I get home tonight, and I'll tweet it out and people can organically share it. It's basically just a keylogger that sits in the browser, and stupid, you'd be surprised how long people leave their browsers open and don't reboot their machine. So, even if they don't reboot it for a week, that's a week of everything that they've logged into getting creds-wise. Also, you can manual packet spoof. Unfortunately, the only source code I have to show you how manual packet spoofing can be used, I sold to a third-party vendor that shall remain nameless, so I can't show it to you. But basically, in a lot of update chains, aside from the 3-part handshake to open up the SSL chain, it just pushes a binary and there's no signature verification on the client side. They're supposed to, but a lot of companies don't do it because it's have to do with verification certs. What that means, essentially, is that you can constantly send packets in groups that assume, okay, if I would have connected, here's a bunch of data that is the binary. And you keep sending this, and what happens is eventually, when they actually do an update, your packets get there first, and it absorbs before it absorbs the original, and it just absorbs. Like I said, I wish I could show you the code, but I like not going to jail. Other methods of social engineering, a lot of people download wares, backdoor the wares, nobody's checking signatures, shit totally works. I have maybe 15 times that I can specifically remember in my entire InfoSec career remember specifically using adult entertainment as a method of like, this program will fucking destroy your computer, but click here to get boobies. People click yes, every time. Every time. It's fucking true, right? I mean, sexist as much as you think it may be, like what Chris Rock says is true. If America was a woman, America would be a big titty woman, and everybody loves a big titty woman. It's fucking true. In general, people click shit, they do. Sometimes you have to get unique about letting their guard down because some people know not to click shit, but everybody clicks shit. We all do it. Okay, so other vectors, right? You can ODE stuff. Image libraries are a great one because they tend to not get updated. Games, web servers. One of my favorite for going after local web servers is internal websites that haven't been updated in a while that have profile pictures. A lot of them use variants of GDLib that is fucking old. There's tons of bugs in GDLib, so you update a profile picture that, you get web browser access. It's awesome. Chat applications are another popular one. There's so many documented bugs in libpurple that have not been patched. And libpurple's in like everything. I really kind of don't know why that's not a bigger deal with activists since they all use it for TorChat, but yeah. Media sharing bugs are really fun because generally when they break, like media tends to break a lot, right? Like how many times have you tried to play a video off the internet that's totally legit and it just doesn't play because insert VLC problem or FFmpeg or whatever because everybody wants to not play nice with codecs, which means that there's constant parsing errors. That generally means that if you're using ODE and a media server, you kind of get multiple plays at the target because nobody's going to check the error, right? They're just used to videos not working. Drivers are a great one. How many in this room have tried to update NVIDIA drivers or ATI drivers at some point and had it horribly shit the bed on their box and not investigated it? Yeah, and you guys are all smarter than the average users, right? Yeah, great place to find ODE. There's also like old day, as I call it, or like one day. This is, in my opinion, the most effective method for getting into anything because at the end of the day, nobody patches. Whether it's too much, it's too hard, they're worried about the updates not being compatible with other shit, they're worried about I don't want to learn the new interface, whatever, right? Like, most software in the world is not new, and that means it has bugs. And the great thing about it is that it's way easier at scale to look up old bugs that haven't been patched because nobody put a logo on it and gave it a name and thought it was important than it is to find ODE, right? About ODE is that while ODE may be great when it works, when it doesn't work, you are absolutely getting investigated. At that point, you're fighting a war against the DFIR person on not getting caught, or at least not getting your payload ripped off, and you're definitely losing the bug. With this, somebody catches you, as long as they can't attribute it to you, fuck it, it's a released bug. Move on. It just looks like a garden variety hack. Physical access, obviously evil made. Nothing else needs to be said about that. And, long con. I mean, insert favorite movie about thieves, right? Like, you make somebody's friend, you sit with them for a long time, you get coffee regularly, and then that one day you pineapple them, you're there to perform tech support if it doesn't work. They don't think anything's weird. Wireless, similar thing. I'm not going to labor on wireless. You all kind of know how wireless attacks work. Also, the new, WPA attack that everybody's talking about is fucking horseshit compared to all the FUD that's out there. Like, if you don't believe me, go read the BSD patch. Honestly, the BSD patch that changes the nonce is non-relevant in a whole lot of commercial router applications because they use their own seeds for nonces anyway because a lot of them have used the nonce to provide their backdoors. It's the fucking truth. So persistence. So persistence takes on a totally different vernacular when we're talking about long-term surveillance gathering, right? When you're a pen tester, persistence is stay in memory, don't write to disk. Well, that's great if you want an interactive shell and you don't want to do something autonomous and you want to stay in for an hour, right? What happens when you want to stay in for 3 years? You're writing to fucking disk, right? Okay, fine, people don't reboot their machines often, but in 3 years, shit's getting rebooted, stuff's getting restarted, new packages are getting installed, and you want to stay on that device. So persistence is a thing, right? I mean, yes, disk writing is a way to get caught, but fucking deal. Obviously, persistence has problems. It's, disk writes are easy to catch. It gets commonly checked. It's really effective, man. Once you're on disk, yeah, you're going to get caught, but once you're on disk, you're on disk. Nobody's getting rid of you. There's multi-platform ways to get on disk, which is what we're going to talk about in a minute. Linux is probably the easiest on disk persistence to provide, mostly because everything that's designed to find on disk persistence is generally based on some level of signature. And the problem with signatures is that really the only way the industry has figured out how to verify signatures up the chain really is based on hardware. And the problem with hardware that gets released with licensed software is that nothing in Linux is licensed. So really, there's dragons there. It's not practical. People don't do it. And, it tends to be quiet. Okay, now we're mostly going to talk about persistence vectors, and then we're going to talk about intelligence gathering vectors at the end of it, and then there's some general, don't do this at the end, and that's pretty much the talk. So first vector, MBR. So this is an MBR payload that I wrote, maybe 3 years ago. It's incredibly simple. All it does is, display this message down here, root is only the beginning, which is not that big a deal. The bigger deal is that it never boots your machine. And this is a primer. Without getting into more explanation, basically an MBR is more or less 512 bytes. 512 bytes is the maximum, but you have to include a partition table. If you want to get fancy with it, you can change the partition table during your infection. But basically, this is where you started if you wanted to. This is where I would start if you wanted to write an MBR payload. Anybody in here not know what a master boot record is? Okay, cool. So yeah, I'll publish the slides, but that's a quick, I would like to write MBR malware. This is where we start. In terms of how do you infect it, on Windows, it's a little more difficult. You have to use driver stuff, which I didn't bother. On OS X, it's not really relevant because they only use UEFI now, so unless you're going after legacy Apple devices, which statistically tend to not exist in the wild anyway, fine. For Linux, this is fucking great because all kinds of Linux systems still use backwards compatible, right? Everybody's BIOS is not set in UEFI only, it's all set in UEFI legacy. The legacy is so that you can install Ubuntu when you put your flash drive in it, because so many of those things are not UEFI only. Yeah, unless your user is locked down, this will copy a payload to the beginning of a drive, and now it's done. It's fucked. I use this all the time. I use this at CCDC. I use this on jobs. It's fucking awesome. So moving on to UEFI, the first thing that somebody will tell you about UEFI persistence problems is like, well, what about secure boot? Well, it turns out secure boot's implementation on pretty much every operating system besides from OS X fucking sucks. And we'll talk about why in a minute. And the great thing is that writing a UEFI binary is way easier than writing an MBR. Because with an MBR, you've got BIOS real mode, you've got a limited amount of assembly you can fuck with. There are rules. UEFI, it's a fucking kernel. You can write that shit in C. There you go. There's a hello world UEFI. So fill print L with do evil shit here. Done. Because I should scroll sideways so you can see the end of the function, but that's pretty much it. UEFI on Windows. So this is great, right? So let us go down the memory lane of the ways Windows has completely fucked UEFI on its own environment. So first, anybody remember the domain 2008 bug where, so like Microsoft released this trick where, they released this feature where they wanted to get rid of the local admin problem, right? So like you have 802.1x on your network, but then like at the end of the day, somebody's gonna just take apart their shit and like get local admin and then fuck, right? So they came out with this thing on 2008 where you could give your GPO an encrypted hash that only Microsoft stuff could decrypt, and that password would get set as the local admin password as soon as they would plug into the network, so that way you didn't have to worry about like get system mimikatz, right? Which was a cool idea. And then in the help manual, like apparently when they released that feature, the original plan was to make a button so that you could roll your seeds, so predictable, and they never come out with that button, and then they published the key in the help manual. Oops. So it turns out they did the same fucking thing with UEFI, right? Where they were like, okay, here's signed stuff in all the chips because Intel sucks our, we like Intel and like everything's cool and we're gonna sign all of our images, and if you wanna sign your own, here's the key. Oh shit. So that happened. And then there was this policy problem where they were like, okay, we'll fix it. We'll release this patch so that you can only do that if you're an admin on the system. Well, the problem is that get system is really fucking easy, and there wasn't really a way to tell the difference between system and hardware system, so that patch didn't work. And they tried it again, which, long story short, didn't work either. And now we're at this problem where even if they release a patch tomorrow that fixes all of the new signing key stuff so that only the appropriate people can sign images, there's still a bunch of devices in the wild, i.e. most of them, that now you can't revoke the old keys because they're still valid. So really, none of this fucking matters because the old key's gonna keep working. On Linux, UEFI is a fucking joke because in short, the way UEFI works is that you into your BIOS interface, you tell it, here's my key I'm gonna sign my UEFI image or kernel with, and then you boot. And before it boots your kernel, it says, I'm gonna check the signature. Yes, that signature's good, I'll boot. If that signature's bad, I won't. The problem is that means you need a way to give your BIOS a third-party key or come with a pre-signed image. Well, okay, really? Linux consistency in the kernel? Right? Like, on most operating systems, it's fucking compiled as part of install, so how the hell are you gonna sign it? At the end of the day, like, yes, there is a way to do this right. Nobody fucking does it, and on most hardware, they don't have a way for you to insert the key manually. So really, until we're 10 years down the line and people are logically being able to implant UEFI keys, just assume it's not there, because it isn't. Apple, yeah, good luck. Their UEFI is crazy, because they own all the chips on their board, and so there's like system on chips that sign the thing that signs the UEFI, and there's stuff out there from Dino Dizovi and a couple other badass researchers on how to do it, but like in terms of it being easy to deploy or practical, but there's other ways to fuck with stuff on OS X, so we'll talk about that in a minute. Okay, so another persistence method is daemonization. So how to do persistent daemonizes. In anything that's Unix-based, the daemonizing, the typical double fork is gonna be your best bet. Why? Because most Linux stuff gets suspended, not rebooted. That's good because that means orphan processes survive. So orphan process, this is like the simple easy peasy 1, 2, 3 of the way that you do orphan processes. You write a fork, you set your SID, you apply any signals that you're gonna use to control your program, which is completely optional, and then you fork again. And when you fork again, you've distanced yourself from the terminal and you've distanced yourself from the TTY. You exist as this orphan process controlled by whatever the init handler is. Another way to do this is to modify or implant your own init descript. Here's an example of a super like bare bones init script. Yeah, you can add lines and stuff. My favorite trick to do with these is anytime you find an explicit directory reference, like here, you can assign directory paths to pipes, and you can put those pipes as commands. Like you can make like a shell file be your pipe. Funny story, space is a valid directory path. I see Dan laughing. It's a valid directory path in Linux, so you can totally have a directory that when you hit ls just shows up as nothing. Just saying. Next. RCD, same kind of deal. Yeah, find an exec, modify it, or add an RCD script. Now your stuff starts up on boot. Systemd, fucking systemd. Luckily, it's well documented, so pretty much like follow the instructions on how to do stuff. And this is a cool little, I didn't know that until I started fucking with it. Turns out that works. Or you can add a cron job. Cron job's great for fileless persistence, especially if you're dealing with a system that commonly has access to the internet, because you can have a cron job that pulls down your payloads dynamically, which is great, because you can add crypto stuff, which we'll talk about later. All right, so there's also user space persistence. Oh my God, so many places to hide in the Windows registry. So many. So these are the default Windows keys on stuff that starts up when you start your computer. You can modify the paths, you can add stuff to the paths, you just put an exe in there, shit fucking works. Boot execute is stuff that explicitly operates on boot. User init is a lot like user DLL or app init DLL. Basically, you take a DLL, you add it to this key, and anytime, I think it's kernel32.dll gets loaded into a program, it also loads your DLL, so you get shared object injection for free. Notify, anytime there's a notify signal on the system, it'll inject whatever it points to. You can modify the Windows shell, period. Because it turns out that for whatever reason, based on its dependency issues, it doesn't sign itself all the time. Like its context changes. I haven't really figured out how to put that in a simple pill that I can deliver to you that is measurable. But trust me, start fucking with the signatures on explorer.exe and see how many times your computer doesn't shit the bed. It's kind of alarming. Default startup locations, services. So Windows services are they're basically just exes with, okay, so like all PE files are pretty much the same. The only difference is their entry point. So an exe typically has winmain as an entry point. A DLL has a DLL main as an entry point, which you can actually change one into the other, which I have code to do and I was going to show you, but again, I sold it and I actually asked the person I sold it to if I could show it and they were like, no, so sorry. And Windows services are no exception. There's like a third, this is a Windows service. There you go. Add these three functions, do some stuff, and add your service to the service directory, and now you get loaded as a service. These are the registry keys that initiate background services. This is a good way to hide from some process managers or procmon or that kind of thing. Browser helper DLLs is fucking amazing because these are shared objects that get loaded. Anytime that a web browser gets, typically IE gets loaded into memory, right? It'll also load your DLLs. What's awesome is like a lot of people like LastPass and stuff like that, right? These password managers that are browser specific, which means they get mapped into the browser memory space. So you can totally take functionality out of open source code like, oh, I don't know, recall, and be like, hey, load, and then when you get loaded, like totally dump your process memory and like HTTP post it base64 encoded via image stenography to like evil.com, and then you just grep the image for like all the LastPass passwords, and you couple that with a keylogger, and you go, okay, start the keylogger for 10 seconds and then send me all that data, and you take the password and plug it into the database, and yay, all the things. App init DLL we talked about earlier. This is the same thing as the other registry key, but I think it's user32. Anytime user32 gets loaded, it loads your DLL. Appcert DLLs is, I actually forget what that was. Sorry. Anyway, it's a path that loads more DLLs. Sorry, this isn't my laptop. I had speaker notes. I don't have access to my speaker notes right now. File association, this is a cool one. You change like the .docx file association to like my evil program, which then calls Word. So you get every document in context. Works really well on like putty keys. So anytime anybody opens this putty key, call my thing that steals it first. It's kind of cool. SGV host, turns out, like, yeah, SCP host is totally broken. It's supposed to sign stuff, but it totally doesn't. There's a really great blog from a live attack that somebody found on the wild Silence that covers SCP host. So SCP host is basically the Windows executable that starts services. So you can add paths. You can add paths and say, hey, when this service gets loaded, also load this DLL, or you can add services in general. WMI. I actually didn't, until I was doing research for this talk, know that WMI could be used for persistence that survives reboots. It turns out it totally can. So you use a reboot, or you use WMI command to like set a scheduled task, which like adds creds or downloads or does whatever shady stuff you want to do. And then at the end, it says run another WMI command. And if that WMI command is a scheduled task, you can set it for run after reboot. So then the next time it reboots, it adds itself. So if your runtime doesn't use files, then you can basically have a WMI command that never dies. It just survives one reboot to make itself last the next one. It's kind of awesome. There's a really awesome Black Hat talk on how to do this. All the other, there's like, this is built into Metasploit, this is built into like Cobalt Strike and a bunch of other like basic tools now. So like, I highly recommend just going to look at their source to find out how it works. But if you want to know how it works under the hood, this is the Black Hat talk that'll tell you how to do it. I didn't think of this, and then just props to Chris. So I asked on Twitter, like, hey, fileless WMI backdoors, like, don't survive a reboot, right? And he was like, oh yeah, just use PowerShell. Well, you have a WMI command that calls PowerShell, PowerShell calls Mimikatz, do all the things.
Can I interrupt for just 1 sec? Lunch is starting momentarily, so we're going to let Vyrus continue on into lunch, so you can stick around if you'd like, or go grab lunch. Up to you.
All right, I'm going to try to go fast. So shortcut hijacks, like change the .link, and all the things, right? Change this, call my shit, have my shit call the original. DLL hijacking, so this is the hierarchy in which every shared object gets loaded on Windows in order. So if you add one here or you change one before it gets to the real one, yours wins. You can backdoor the PE file, okay, so now we're going to talk about code caves, which I mentioned earlier when I was talking about Backdoor Factory. This is essentially how Backdoor Factory works on all of its subs. So somewhere in the rat's nest of a program, it's executing, and somewhere there is assembly that says jump somewhere, right? And that somewhere does I should go back, jumps to a place, usually a function, some stuff happens, and then it like pop, right, go back to where you were. Basically, you take that jump and you make it jump to my code. Your code calls the original code, and then the original code jumps back to where it was. Yeah, that pretty much works on everything, because that's how assembly works. You just change the jump vector. And this is where I talk about like the modern, this is pretty much like, if you want to backdoor a file and you don't want to get caught, this is what you do on Windows right now. Like, this is totally where, this is fucking scandalous. So Linux, so you can LD preload stuff. This is a GitHub for an LD preload backdoor. Go look it up. I'm not going to bother pasting it here. Kernel module, you can write a backdoor kernel module. This is a POC kernel module that's totally free on the internet. Totally use it, nothing finds it. Kernel modification, you can actually replace the kernel itself. I've totally on gigs been like, oh, I want to backdoor this kernel. Oh, is the kernel source on this box? Sweet, I'll just add my backdoor into the source and then recompile it with their fucking compiler. So awesome. Syscall hijacking. Syscall hijacking is a little harder. I don't actually know if this is in Backdoor Factory or not. I think it either is, or me and Josh were talking about putting it in there and we didn't, or something like that. Basically, you backdoor the kernel, which is essentially an ELF, which I'll talk about how to do a standard ELF backdoor in a minute, to change a syscall direction. So you have syscalls, right? Like 1 is write, 2 is read, like whatever. And you say, okay, no, instead of pointing to this as read, point here. And you add a section to the exe, or to the ELF, that says do some evil code, and then you call the original place that was supposed to call the syscall, and now that syscall is your backdoor. And this is, I'm going to fly through these because we're running out of time, but this is like ELF backdooring 101. You basically change the header table and the section table to add a section, and then in that section you hide your shit, and then if you're dealing with a compressed kernel, then that ELF is this VM, this is your ELF. So you unzip that, modify your ELF, stick it back in, add there. You can patch PAM. These are two source examples of modifying PAM in Linux to do shady shit, like every time the password is changed, send it to me over some covert channel. You can use set UID root binaries, which is you modify a non-root binary to run as root and then not lose those permissions when it exits. This is a really good example of how to use that to produce a backdoor. And this is kind of the example of like once a box is owned, it can never really be unowned. Elf backdoor, you can backdoor an elf itself, like backdoor ls or backdoor load. Again, backdoor factory, learn how to do it. OS X user space. So this is supposed to be hard because of this thing called SIP, which is like system intercept some crap. I keep forgetting what the acronym names. But basically, it's only OS X stuff is supposed to be able to write to special places on the OS X file system. The problem is that applications are allowed to write to / application. So if you pop an application, who fucking cares? You can write a kernel module. They call them K extensions or kernel extensions, but it's just a kernel module, and you pretty much use the same syscalls. You can backdoor a Mako file itself. Again, read backdoor factory. It totally does it for you. You can add launch HDs. This is what a launch HD daemon looks like. Again, there's a path to an example script, and that script can be an Apple script, and there's all kinds of documentation on how to do horrible things on Apple script. And this is a cool trick for anybody that decides to do that, because by default, loading an Apple script will load a terminal window. That makes it not do that. You can add a login hook. Apple actually documents how to add a login hook. This is deprecated, but still tends to work. Use it. Or you can do constant process migration, which, it's messy and typically involves some level of memory corruption, so I don't really advocate using it, which is why I didn't really get into the weeds on how to do it. Credentialed access is great. Credentialed access can be a double-edged sword, especially if you're accessing third-party resources, right? Like you steal somebody's Gmail creds, but every time you log in their email, your location is going to be known. So that's when you do things like leave a proxy on their box that's HTTP. So that way you can give it a job and tell it, hey, the next time you check email, make a copy of it for me, because you don't want to get caught in their logs. Phone backup files are a great one, especially since most people actually don't encrypt their phone backup files. They're supposed to. There's tons of functionality to do it, but because it takes longer to uncrypt or to decrypt and then to update a phone, a lot of people don't do it. So you can find a backup file on disk. And what I like to do, since phones get weird in terms of environment change, is hide code on the phone backup such that the loader in, like for example, iTunes will execute machine code when it parses the download, but it won't go to the phone. So the phone is holding this code that effectively does nothing to the phone. But as soon as they plug the phone into the computer and they say, make me an image, right, it references the old image, and in loading the old image, it runs your exploit code, which I had source to do, but I'm using that in a live engagement on the side, so sorry. All right, intelligence gathering, trying to speed up, guys. I know we're totally out of time. So this is basically how you build a keylogger on Windows. There's a function called get async key state. You call that and say on every key, is this key being pressed, is this key being pressed, is this key being pressed, and if it is, you write it. Which sounds really fucking loud, and it is, but apparently everybody's used to shit being loud on Windows because this is how Empire does it, this is how Metasploit does it, this is how commercial shit on the fucking darknet does it, and nobody fucking cares. On Linux, your keyboard is a device, fucking cat, HTTP post, done. This is a Linux keylogger that I ripped off years ago and have been using the guts in all of my implants for years now. On Apple, because everything's a fucking pain in the ass in the fucking Apple universe, you have to create an event. And the problem is you can't create an event for arbitrary actions. You can only create an event for certain shit. So in this, you create a string for key. You basically create an event for every key. You turn each key into a string, and you say, when this event happens, do a thing, and then you run a loop that listens for those events, which is fucking complicated. So this is a chunk of code that does it for you in C, and then I actually use this in Go, and in Go I call like c.startLogger, and it spits out data to a buffer that Go can traverse. Which I couldn't post the Go code because that's part of an implant that, for lots of reasons, I cannot disclose, but I can disclose this because this is just arbitrary C to build a keylogger on OS X. Screen capture video. This is, I have code to do this, but I just didn't have time to comprise it into a simple format. It's kind of all spread out in the implant that I use it in. But basically, there's a function in there or there's stuff in there where you create what's called context. So you create a context, which is a placeholder for stuff. And you say, hold all the stuff on the desktop. And you create another context that says, hold all the stuff in any bitmap that I make. And then you call this function over and over again, which is, take a bitmap from context A and store it in context B. And then you send context B someplace. This is a video capture on OS X, which again, I didn't bother to write myself because I stole this a while ago and have been using it, so go steal theirs. This is image capture, same deal. On Linux, you can use XWD. Not always relevant, because a lot of times you're just going to be capturing from the TTY. There's TTY spy code out there that's public, but it actually doesn't compile very well on modern operating systems, and I haven't figured out why. I honestly haven't used it that much, because usually a keylogger on Linux works just as well, and the keylogger that I showed you earlier, I've never had fail on me, so I've never had a reason to do this. Webcams. Oh my God, like manually going into the API of every single system in order to build platform-independent malware to do shit is a giant pain in the ass. Just use OpenCV. Yes, it's huge. It's 2017. Nobody cares. Like, we're not hiding malware on floppies anymore. The fact that your malware is 10 megs means fuck all. And it's multi-platform. Like, I think I included the source. Yeah. Here is Go code from a payload that I use all the time, and here you go. This is capture shit from a camera. Let me tell you, going on pen tests and showing people not just shells, but the faces of the people while they're using the box that has the shell, holy fuck, makes people shit the bed. Audio, same thing. Turns out port audio works on fucking everything. And like, here you go, block of C which says turn mic on and listen to shit, stream to me. Holy fuck, like bugging conference rooms with laptops, people freak out. Browser data, so I'm just gonna go through these super quick because they're not really relevant. Like, yeah, there's some quick ways to do like decryption, and these are some sources that I'll release because I'm gonna release the softs. But basically, if you wanna steal stuff from browsers, pop a Nersoft utility on there and just run it. Like, they have stuff to do all kinds of, like, every browser in the world, like Outlook and whatever, you just run this and it steals all the creds, all the codes, all the things. Email history, these are more general and we're like way out of time, so I'm just gonna like go real fast. These are like, you can perform that email backup if you have a proxy on somebody else's machine. That way you don't have to worry about history grepping. You can, if you get really shady or you get really good access, you can redirect the MX record to your server and then change the IP record to go back to the original server so that you just backdoor the SMTP server. This is great because while Gmail keeps logs of things that log into it, the clients don't. So every time they log into an email, they're just sending it to you. There's no fucking record of that, right? You can steal the backup file. These are all places that the Outlook, that email clients tend to hide tend to store their backup directories, and none of them are encrypted by default. That tends to work. And again, like, just use Nersoft. Like, Nersoft stuff will totally run all the things. Location data, this is a fun one. So a lot of times, like GeoIP functionality, if you're talking to hardware, you'll get crypto bugs because the APIs are different. So just go, what's my IP? Ping something in the public and be like, Google, what's my IP? And then do GeoIP. GeoIP databases are getting better because since people are caring more about privacy and turning geolocation shit off, more and more companies are putting forth public resources into making their geolocation databases better. Wi-Fi keys, this is a link that'll tell you how to steal Wi-Fi keys. Again, it's super documented, trying to save stuff for time. WPA supplicant, you can go through the config and backdoor stuff. Document files, this is a fun one. A lot of people overlook this. If you get on a box and you really want to mine into what somebody's doing, steal all the document files, normalize them all to text, which is a bash script, super easy, and then put them on a local server and install Apache Nutch and have Nutch index that local server. Bam, personal search engine for somebody's life. Shit works so well with like Twitter grabs and Facebook grabs and email grabs. You just put it all on one document and fucking NSA the shit out of them. Chat logs, these are all the, these are places where libpurple and stuff source chat logs. Yeah, password managers, again, like password managers are typically binaries. Backdoor them. Run a keylogger for 10 seconds. Background processes. All right, well, the rest of it isn't really relevant, but I was going to cover a packer and I was going to cover some dynamic execution stuff, but all right, I'll try. Hit me up. Sorry, guys.
Where can we get the slides?
I'll publish them.
Where?
I don't know. It'll be a link. Slides, I use slides.com. There'll be a slides.com link. I'm sure I'll get ShellCon to like tweet it out or something.
All right, thanks again.